You're good.
This is our final project for calculus. We're going to demonstrate the calculus behind the simple act of dropping a ball. We need to find the velocity at 5 feet, 4 feet, and the final velocity of when the ball hits the ground. And we're going to find this from dropping it at a height of 6 feet. Formulas we're going to be using are the acceleration due to gravity, which is 9.8 meters per second squared, and also the displacement, which is gravity times time squared divided by 2. And stop it there.
Good.
This is going to be the actual demonstration of our project. Right here is the ball at 6 feet, the height at which it's going to be dropped. When it's dropped, it's going to pick up velocity, and we're going to try and calculate it at 5 feet, and then again at 4 feet, and then again its final velocity just before it hits the ground.
And next you drop the ball.
Okay, this is our actual demonstration of our project. Here's the ball at 6 feet, the height at which it will be dropped. We are going to calculate the velocity at 5 feet, and then again at 4 feet, and then for the last time right before it hits the ground, the final velocity. So, here we go.
You're good.
Okay, like Steve said, forgot the formula name.
Okay.
Thank you, Steve. Now, like Steve was saying, the formula for displacement is D equals 1/2 times the force of gravity times time squared. And I just rearranged it to make it look a little more easier. And we know that the force of gravity is 9.8 meters per second squared, so we can just go ahead and plug that in. So 9.8 divided by 2 equals 4.9, then t squared, and there's your displacement formula. All right, and what we're trying to do is find the velocity at those times. So first we need to find the velocity formula. And to do that, we need to derive. And in doing so, you take the exponent of t squared, so 2 times 4.9 equals 9.8, then for the exponent n minus 1, so it'd be 1, so 9.8t is your velocity formula. And also one more thing, because we forgot, this is in meters, so 1 foot is equal to 1.3048 meters. It's your conversion factor.
You're good.
Okay, so question 1, que hora? Spanish, yes, I know my Spanish. What is the time? We would start out using the displacement formula to figure out what the time is. So we'd start out with D is equal to 4.9t squared. Okay, now that we have that, we need to find how far it traveled at 5 feet. It traveled from 6 foot to 5 foot, so that would be only 1 foot. And in our conversion factor, 1 foot is equal to 0.3048 equal to 4.9t squared. Okay, then solve for t. So pretty much divide both sides by 4.9 dot dot, and I need my calculator. 0.3048 gives you 0.0622 is equal to t squared. Get rid of the t squared, square root of both sides. T is equal to, give me a sec, 0.2494. That would be seconds. And if you want to know, that's latents. That's French. Okay, now we have the time. Right there. So we can go straight to our velocity formula, which was v equals 9.8 t. And simple as that, just plug in t into t. You get v is equal to 9.8 times 0.2494. And v is equal to 2.444 meters per second. Voila, and that gets your velocity. And here's another knowledgeable thing for you. Actually, I spelled that wrong. Hold on, just. Don't ask me how to pronounce it, but that's German for velocity. And there you go. That is your velocity at 5 feet. You can turn the video. We'll be walking back and forth. Just so you
Okay.
know.
Okay.
Save some time because I don't feel like doing the other two. At 4 feet, you'd get 3.457 meters per second. And your final velocity, which is 6 feet since it was a 6 foot drop, you'd get 18.933 meters per second. And in doing so, it'd just be like, at 4 feet would be 2 feet drop, 6 minus 4. So instead of putting 0.3048, you'd multiply that by 2 since it's 2 feet, then go through the whole step, blah, 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 you get your time, attempts, then your velocity, whatever that is, and you get your 3.457. And same with your final. And that about wraps up our project. Go. Darn it. Just drop the ball on the ground.
Okay.